Hello everybody, my name is Walter and this is episode 7 of my Redstone Commands Series. In this episode I want to give you a quick overview over NBT data. So what is it, how does it work, and what can you do with it? So let's start with some basic information about NBT data. So NBT is short for non-binary tag, and it basically means just additional data, some of which is optional, some of which is arbitrary. NBT data is used to store additional arbitrary data of block entities and also entities. It can have various types. It generally is usually some kind of numeric type, but it can also be text. NBT data applies to entities and also certain blocks, which are usually called block entities. In earlier game versions, they were also called tile entities, so you may find both names for them. Those block entities are usually blocks that have some kind of internal data, like an inventory, like this hopper here, which also has some kind of timer involved with pushing the items out. Or, for example, the signal strength of a comparator is also NBT data. And obviously, entities themselves also have NBT data. NBT data of a block entity can be copied using the control middle mouse combination. So you have seen I have something in this inventory here, and you can also see here the inventory or the hopper has NBT data copied with it. And if I place it down, you can see it copied down the inventory. So that's how you can copy NBT data. It doesn't work that well with usual entities, since you can see now I have a spawn egg and it's without any NBT data. So there are some exceptions to this rule. Next up, we have using NBT data within commands. When you're doing that, you need to follow the syntax you can see here. So the NBT data is within fancy brackets. So those are not the round brackets, but the fancy brackets. And each NBT tag follows a simple pattern of the name, double point, and then the value. And then if you are finished, you just close the bracket or you put in a comma and then the next NBT tag. The values, generally, when they are at least numeric in nature, are the actual number plus an optional type. I'm saying optional because if you don't specify it, it will be integer for whole numbers and double for floating point numbers. You have a multitude of different types available, but those I will cover in more detail in a later episode. But for now, you have things like Boolean, you have whole numbers, you have decimal numbers, you have text, and then you have compound and array. Compound means that instead of a value, you actually open up with a new NBT data. So you start again with a fancy bracket, which you need to close again at a later point, obviously. And in them, you have again this pattern of name double point value. And array has the rectangular brackets and is just a list of several items with the same pattern. They can be compounds, but generally they are usually things like just numbers. Subsequently, with compounds, you are not limited to a flat hierarchy, but can have a nested hierarchy. Also, the type, if you're using, for example, a double or a boolean or something like that, is generally defined by just a simple letter following the number. So you just write number and then, for example, S, which stands for short. We'll see a few examples in short. NBT data can be used to specify more detailed what you want to do in a command. You can also, if applicable, mix block data and NBT data. So this is if you're talking about a block entity. In that case, you usually have the block data before the NBT data. With NBT data, similar to block data, you can do two things. You can specify what kind of entity you want to place, or you can specify what kind of entity you are looking for. So in this example here, I am summoning in a cat in a specific position, and I'm adding NBT data. And here you can see the summon command, for example, separates the entity I want to place from the NBT data. So some commands have this strict separation. Other instances, especially when you're talking about block data or well, block entities, have them right next to each other. So in this instance, I'm just saying, okay, the cat has no AI, so it won't fall, it won't move, it will not do anything. It's also sitting and it's oriented in a certain direction. And here you can already see this is an array of two floating point numbers. Basically horizontal and vertical orientation. And if I click on that, you can see now I have a cat here. This example here is a setBlock command where I want to place just a sign with a certain orientation, so block data, and then NBT data. And here you can see when I'm placing this sign, I have first block data and then the NBT text. And here I'm just saying, okay, what is the text 1? So the text in the first line, then the second line, third line I don't specify, so it's kept empty. And then text 4 is a text that has actually a command embedded, which I can activate by right-clicking on the sign. So you can use NBT data, for example, to get a sign that actually does something when you click on it. The text on a sign follows the JSON text format, which I will also cover in a later episode. Lastly, when you want to check for specific entities, you can do this in, again, two ways. The first is when you are using a target selector. So here I'm using a target selector for all players, and then you have the target argument or the select argument of NBT. And then you just specify the NBT data you're looking for. In this instance, as you can see, this is actually a compound. In this instance, I'm looking for a player that has an oak sign in the right hand. And then it well, sends a message to that player. So press the button, nothing happens, I get a sign, and I get the message. I have the sign now in my hotbar, but not in my hand, and I don't get the message again. And so on and so on. If you're filtering for certain blocks, as before, you basically have first the block data, if applicable. I could also add a certain phasing, for example, here. In this instance, I'm just looking for a hopper with no items in them, so empty inventory. So execute if, and then just checking for this hopper here. And if that hopper is empty, I'm again producing a message. So I click the button. Apparently it's not empty. I empty it, and now I get the message. So pretty simple to check for certain conditions. So now you've seen how you can use NBT data in commands. It's time to talk about what NBT data is actually applicable, or how you can figure out what NBT data you can use. For that you have basically two ways. And the first is using an entity and just looking at the current NBT data of that entity with the data get command. The main problem with that is, since some NBT data is optional, you will likely not have a complete list this way. There is also no autocomplete function for NBT data in the game currently, so you are kind of out of luck with this. But nevertheless, let me show you this with this example here. So we have this ampersand here. And if I use the data get command, or in this case an entity, for the entity I'm currently looking at, I get a list of what this entity currently has. This list can be rather short, this can also be very long, and even longer than you can scroll in the chat window, for example, if you try it on yourself. Nevertheless, what you can see here are the different parts of the NBT data. You can also already see this here is a compound, so you'll see the NBT data starts, and then the first NBT data has actually another NBT data as a value. That's a compound. Here you can see a value without a type. And you can see the other types usually have, or the other values usually have some kind of type. So this here would be floating point, this is a double, this is short, this is a byte, and so on. You can also see we have several arrays in here. So for example, the items in the right and left hand, and the 4 equipped or non-equipped in this instance armor pieces, and so on. What you won't find in here is a tag concerning gravity affected, or if the ampersand is gravity affected, or if the ampersand has an AI, which the ampersand could have potentially as a tag, but since those are optional and I just place this down without doing anything, it's not in there. If you want a complete list of applicable NBT data, you will have to look into the Minecraft Wiki. The link for that is in the description. Finally, let's cover how you can change NBT data after the fact. So for that you have several ways. The first one is rather brute force if you're talking about a block, or well, block entity. And that is just replacing that block with another block with changed NBT data. So with the set block command or the fill command, or you can also clone it in. It's also an option. So in this instance here, I have a hopper with some string in there. And if I click this button here, nothing changes. But if I remove the string again, click the button again, you can see the string is back. And that is because I used a set block command that placed the hopper with one stack of strings in its first item slot. Pretty straightforward, actually. Another way is to manipulate it using any kind of interaction which can change certain NBT data. So for example, you can change the position of certain entities by just nudging them around, or you can change the inventory manually. Well, similar. And the last is using the data command to directly override the data. So in this instance here, I've shown you this example in an earlier episode already. I'm basically using this command to, well, look for items in a certain distance, and then I'm overwriting NBT data. And in this instance, I'm looking at the NBT data concerning the motion, so in which direction and how fast is it moving. In this instance, I'm giving it a movement speed directly upwards. So if I activate this and throw in an item, you can see it starts to bounce. And I can do this with as many items as I want, since I've used the execute command to separate this into different branches, which is a bit of a downside of the data command, since this only works usually on a single entity, but as I explained in an earlier episode, you can use the execute command to get around this little limitation. And with that, we have reached the end of this episode about NBT data. I hope you enjoyed it, and well, see ya!